a block slides from an inclined plane, and the inclined plane is in such a way that the first half of the incline is smooth and the second half of the incline is rough. Basically, the length of the smooth and the length of the rough surfaces are of equal lengths. Then if it is rough, it has a coefficient of friction mu. If the coefficient of friction is mu and it is in such a way that it slides from the top and comes to rest at the bottom. If it slides from the top and comes to rest at the bottom and the smooth and rough surfaces are of equal lengths, then find the coefficient of friction. That is the question. So let us name the points. So this is the beginning of the journey. Let's say A, and here is where the smooth incline stops. I mean ends, let me call it B, and at the bottom, let me call it C. So basically, this object starts with 0 velocity at A and goes to B. By the time it reaches B, here the velocity is not 0. Some velocity it picks up. Let us call it V. And from there it finally slows down. At C, its velocity comes to 0. So during the first half of the journey, the acceleration takes place. During the second half of the journey, deceleration acts and then it comes to stop. So basically, since the lengths are involved and the acceleration as such, we know it is very similar to the previous question. So v square equal to u square plus 2as equation we can use. Since the entire length of the incline, if you take L, the smooth incline of length L by 2 and this as L by 2. Or the other way, you consider smooth inclines, the length of the smooth incline is S, length of the rough incline is also S, because they are of equal in lengths. So basically here, for the first part of the journey, initial velocity is 0, final velocity is V. Second part of the journey, initial velocity is V, final velocity is 0. So what is the acceleration and deceleration in the first half and the second half? You know, when the inclined plane is here, when its mass is m, and especially when the angle is theta, then you know that the downward force is mg, and this is mg sine theta, and this is mg cos theta. So this is mg cos theta, and this is mg sine theta. So when the plane is smooth, the downward force here during this first half, only the downward force mg sine theta acts. When you equate it with ma, the acceleration for the first part is only g sine theta. Hence, for the first part, if you write, you can write it as first part end, it gains a velocity v. The initial velocity of the first part is 0. So v square equal to 0 square plus 2 into acceleration is g sine theta into s. During the second part, look at the second part now. Here in this second part, you see, because the surface is rough, then there is a coefficient of friction mu. When this block slides down, the friction will act in the upward direction. That frictional force is equal to mu times normal reaction, and the normal reaction here is mg cos theta, so it is mu mg cos theta. Then the net force downward equal to, like in the last problem, mg sin theta minus mu mg cos theta. So F net force equal to mass into acceleration, which is mg sin theta minus mu mg cos theta. So which is having greater sign, don't worry about it, the problem will tell. So A equal to g sin theta minus mu g cos theta. So this is the second part. So the second part, if you write the equation, for the second part, initial velocity is v, final velocity is 0. So for this problem, 0 square equal to v square plus 2 into acceleration is g sin theta minus mu g cos theta into s. So here v square is equal to 2g sin theta s. Here v square is equal to minus, because when this v square comes to this side, it is minus. When you multiply this here, we don't even put to negative sign here. G into mu g cos theta minus g sin theta into s. Since the left hand sides are equal, right hand sides will also be equal. Hence equating this here 2g sin theta into s. Here 2g, take it as common, mu cos theta minus sin theta into s. So s and s will be cancelled. 2g will be cancelled. So sin theta equal to mu cos theta minus sin theta. So 2 sin theta equal to mu cos theta. Hence mu is equal to 2 sin theta by cos theta. So it is 2 tan theta. If the incline is so in such a way that the half of it is smooth and half of it is rough, when the block slides from the top comes to rest at the bottom, means the coefficient of friction of the second part of the rough surface is 2 tan theta.